Hello and welcome back to the Master Civil Engineering. In this video, you will learn that how to perform the calculations for the compaction test to draw the compaction curve and to get the maximum dry unit weight and optimum moisture content from the compaction curve. And also in this video, we will learn that how to draw the saturation line for 80% and 100% saturation. Okay, I have been given a question which states that the following data refers to a compaction test as per the Indian standard light compaction. You can see a table having three columns. The first is the trial number, second is the mass of moist soil in kg, and third one is the moisture content in percentage. So for trial number 1, mass of moist soil is 1.80 kg and corresponding moisture content is 8.5%, and so on for the rest of the trials. Okay, if the specific gravity of soil grains was 2.7, we have to plot the compaction curve and obtain the maximum dry unit weight and optimum moisture content, and then we have to plot the 80% and 100% saturations line. And for the third part of the question, if it's proposed to scare a relative compaction of 95% in the field, we have to find the range of water content that can be allowed. Okay, so coming to the solution of this question. So first in Excel you will draw the we will draw a table having 8 columns. We will perform all the calculations in Excel. Okay, the first one is the trial number, second is the mass of moist soil, third one is the moisture content, and fourth one is the weight of the moist soil. Okay, so weight of moist soil in kilonewton, it is simply mass of moist soil, that is like equal, then bracket, then select the mass of moist soil for trial number first, multiply it with 9.81, that is the acceleration due to gravity, and divide it by 1000 to get the weight in kilonewton. Okay, so it is 0.0177 kilonewton for the trial number first. Okay, then simply select the cell of the first trial number, that is weight of moist soil for trial number first, and drag it till the last row. Okay, let us simply drag it till the last one. Excel will automatically calculate the weight of moist soil for the rest of the trials. Okay, then the bulk unit weight. So bulk unit weight is I have already given the formula. Bulk unit weight is weight of moist soil divided by the volume of the mold. For IS standard compaction light, IS standard test for light compaction, volume of mold is 1000 cc or 0.001 meter cube. Okay, so simply divide weight of moist soil, that is 0.0177 for trial number first, by volume of the mold, which is 0.001. Okay, and press enter. You will get the bulk unit weight for the first trial. Then similarly select the first cell and drag it till the last row, and Excel will calculate the bulk unit weight for the rest of the trials. Okay, then dry unit weight. Okay, you can see the formula for the dry unit weight. It's bulk unit weight divided by 1 plus water content. Okay, so write equal, then bracket, then select the bulk unit weight for the first trial, that is 17.66, close the bracket, divided by, again bracket, 1 plus, okay, then the moisture content. So moisture content is for first is 8.5, so select it and divided it by 100. Okay, then close the bracket, press enter, and you will get the bulk unit weight for the dry unit weight for the first trial. Okay, so for first trial it's 16.27. Similarly select the first cell, drag it till the last, and you will calculate the dry unit weight for the rest of the trials. Okay, you can see in Excel we can easily and quickly perform the calculation. We just have to calculate for the first, and then Excel will calculate for the rest of the trials. Okay, so this gives us the dry unit weight for different trials. Now it's time to find the dry unit weight in terms of the saturation. So for 80% saturation, you can see the formula for the dry unit weight in terms of the specific gravity, water content, and saturation level, that is gamma T is G into gamma W, which is the unit weight of water, divided by 1 plus WG divided by S. W is the water content, G is the specific gravity, and S is the saturation. Okay, so for the first trial you will write equal, then bracket start, value of G is 2.7, okay, multiply it with the unit weight of water, which is 9.81, okay, bracket close, then divide, then again bracket, that is 1 plus, okay, W for the first trial number, moisture content is 8.5%. We will take both water content and saturation in percentage, so directly take moisture content as 8.5, multiply it with G, that is 2.7, and divided it by the saturation, that is 80%, because we have to find the gamma D for 80% saturation. Okay, I have directly taken 80 in terms of percentage because I am taking moisture content directly in terms of percentage. Okay, so then close the bracket and press enter, and you will get the gamma D for 80% saturation for the first trial. Okay, similarly, select the first cell and drag it till the last. Excel will give us the value of gamma D for 80% saturation for the rest of the trials. Okay, so this is the gamma D for saturation level of 80% for different trials. Okay, you can see in each cell value of moisture content has been taken as different. Only thing which is remaining same is G and the saturation level. Okay, but moisture content W is changing for different trials. Okay, similarly, if gamma D for the saturation percentage equal to 100%, you will select the first cell, then write equaled, then bracket, then value of G, which is 2.7, multiply it with 9.81, that is unit weight of water, close the bracket, divide, then again bracket. You have to take care of these brackets, okay, to correctly calculate the value. Okay, then 1 plus W, okay, water content for this is again 8.5, directly multiply it with G, which is 2.7, divide it by the saturation, which is 100%. Okay, then close the bracket, press enter, and this will give us the unit dry unit weight for 100% saturation for trial number first. Okay, similarly, select it and drag it till the last row, and Excel will calculate the gamma T for different moisture content for saturation percentage equal to 100%. Okay, so this completes our calculation table, okay, for this compaction test. Now we are ready to draw the compaction curve. Okay, after performing the calculations for the compaction test and calculate the value of dry unit weight for 80% saturation and for 100% saturation, in another sheet in the same Excel file, we will draw a table having 4 columns. The first one for the moisture content, second one for the dry unit weight, then third one for the gamma D for 80% saturation, and third one for gamma D for 100% saturation. Okay, and then you will select these 4 columns, click on the insert, go to the charts, and click on the scatter with smooth lines. Okay, though this will give us our compaction curve chart. Okay, increase the size. Okay, delete this chart title. Okay, add the axis titles. Okay, we'll delete these series. Okay, for horizontal axis, you will write water content or moisture content. Okay, so write water content, that is W in percentage. Okay, okay, and for the vertical axis, you will write dry unit weight in kilonewton per meter cube. Okay, okay, we have to do some modifications to the chart. Okay, so first, because our value of dry unit weight is not less than 15, so we will take the minimum value for vertical axis as 15. Okay, double click the vertical axis, take the minimum value as 15. Okay, and maximum value as 20. Okay, so because dry unit weight, let's take it as 20. Okay, Okay, and let's take the major as 0.5 and minor as 0.1. Okay, so let us make tick marks visible for major type as cross and minor type as inside. Change the color for these. Okay, so let's take the color as black, increase the width. Okay, now we can clearly see the values. Okay, similarly for the horizontal axis, you will double click it. Again, change its thickness to 1 point and color to black. Okay, for the axis options, we'll take it's correct, major as 5 and minor as 1. Okay, let's make the tick marks visible. Okay, that is for major type as cross and minor type as inside. Okay, now we can see clearly the values. You can also increase this thickness. You can also change it to black and increase the width to 1 point. Okay, so this is our compaction curve. Okay, now we have to find the value of the maximum dry unit weight and optimum moisture content. So simply on the graph, you will look at the peak value. Okay, and at peak value, you will draw a horizontal line. Okay, so at peak value, here is my peak value. So at this point, you will draw a line. You can see. Okay, just color to black. Okay, so this gives me the value of the dry unit weight. So it's approximately 17.45. Okay, and optimum moisture content, again from the same peak value, you will draw a vertical line. For dry unit weight, you will draw a horizontal line, and for this, you will draw a vertical line. Okay, so it's approximately like 15.2. Okay, 15.2 is the value of the optimum moisture content, because for horizontal divisions are 1, that is this 15, this 16, 17, 18. If you want more precise value, you can increase the divisions for the horizontal axes in Excel, and you will get the more precise value. But here it's close to 15.1 or 15.2. Let's take as at 15.2. Okay, and the value of dry unit maximum dry unit weight is 17.45. Okay, so this gives me the value of the maximum dry unit weight. So maximum dry unit weight is 17.45. Okay, so symbol, insert a symbol, that is gamma D. For my case is 17.45. Okay, and value of optimum moisture content, that is O, is it's 15.2. Okay, this is in kilonewton per meter cube, and this is in percentage. Okay, okay, so value of gamma D, that is max gamma D. Okay, let's write it as max. It's 17.45 kilonewton. Okay, from the graph. And optimum moisture content is 15.2%. Okay. So this gives me the value of gamma D and optimum moisture content. Now we have to also find the gamma D for the relative compaction of 95%. Okay, so we will find that in the next sheet. After finding the maximum dry unit rate and optimum moisture content, we will now find the maximum dry unit weight to be achieved in field for a relative compaction of 95%, and also the range of water content that can be allowed. Okay, so relative compaction, it's given by uh, gamma D field, that is maximum dry density to be achieved in field, divided by the maximum dry density achieved in the lab. Okay, so for our case, relative compaction is 95 gamma D field divided by maximum gamma D is 17.45. So this gives us the gamma D field, that is maximum dry unit weight that we can achieve with relative compaction of 95%, the field to be 16.58 kilonewton per meter cube. Okay, now we have to find the range of water content for this. Okay, so on graph at 16.58, okay, you will draw a horizontal line. Okay, so it's 16.58 approximately here. Okay, you will draw a horizontal line. Okay, so you can see this horizontal line cuts the compaction curve at 2 points. Okay, okay, it cuts the compaction curve at 2 points. So these 2 points are our range of water content. Okay, from these 2 points you will draw a vertical line. Okay, so first one, you can see it's touching at approximately 10%. Okay, and for the second one, it's greater than 19, slightly greater than 19. So you can see the range of water content which we can accept in the field is between 10 to 19% to achieve the 95% relative compaction. Okay, so this is how you can perform the calculations for the compaction test as per the Indian standard, and draw the compaction curve, and also the 80% saturation line and 100% saturation line. The orange one, this is the 80% saturation line, and this gray one, it's the zero air voids or 100% saturation line. Okay, okay, this peak value is the peak value. If you draw a horizontal line from the peak value, it will give you the maximum dry unit weight. Okay, and the value on the horizontal axis will give you the optimum moisture content. Okay, and these two values, that is 10 to 19%, is the range of water content that can be allowed in the field to achieve the relative compaction of 95% for a dry unit weight of 16.58. Okay, I hope the solution video was clear and effective, and you definitely learned something new. If you found this video helpful, you can subscribe to my channel and share this video with your friends. Also, if you want this Excel file, you can write below in the comment box. Okay, and I will give you link to download this Excel file. Okay, thanks for watching Master Civil Engineering, and stay tuned.